Hello everyone, my name is Ahmed Al-Soda, master's degree in medicinal chemistry at Mansoura University. Today we'll talk about basics of organic chemistry. Before we start our session, we have to ask ourselves two important questions. The first question will be about how to study chemistry in general. To study chemistry, the key element to study chemistry is through imagination. You have to imagine the movement of electrons during breaking of bonds, formation of new bonds, or transfer or movement from atom to another. I hope this session will help and aid to put your imagination on the right course to study, learn, even love chemistry. The second question will be, why do we study chemistry? In our universe, we have many galaxies. Going through all these galaxies, reaching our galaxy to our planet Earth, which is inhabited by many living organisms, like plants, animals, and human beings, all of which are consisted of body structure, organs, tissues, and cells, which are mainly built up from atoms and molecules, which are chemistry. But to be more specific, we will talk about our human body structure for a specific organ that God have differentiated us from animals, which is the brain. The brain controls all our body functions through sending electric impulses through neurons and through three main neurotransmitters, which are dopamine, love transmitter, serotonin, happiness neurotransmitter, and flight or fright, norepinephrine neurotransmitter. Going through these structures, which are mainly organic chemistry structure, they are made of the smallest building unit of matter, which is the atom. Now we have reached the smallest building unit of the matter. We will talk about the atomic structure to explain our next properties in this session. We will start with the nucleus, having around it electronic shells, each having the nucleus having a protons, positive protons, and neutral neutrons, while the electronic shells containing the negative electrons. About the protons, it symbolizes for the atomic number found in the periodic table, while the summation of the protons with the neutrons give us the mass number of the atom. While electrons, the negative electrons, is used mainly in chemical reactions. Electrons are found in orbitals, where each orbital carries 2 electrons only, found in opposite directions, rotating and spinning in opposite directions, 2 electrons maximum. These orbitals are found in a set of subshells, which are S, P, D, and F. Each subshell contains a number of orbitals. Like S have 1 orbital, so maximally it carries 2 electrons, while P has 3 orbitals, so maximum 6 electrons, D 5 orbitals, and F 7 orbitals, 14 electrons and 14 electrons. These subshells are found in the electronic main shells. We have a number of electronic main shells, which are 7 main shells, named alphabetically from K to Q, K, L, M, N, O, P, and Q. Each main shell contains a set of subshells, like K contains only S subshell. Thus, it carries maximally 2 electrons. While L contains S and P subshells, so maximally it carries 8 electrons. M have S, P, and D, so maximally it carries 18 electrons. Starting from N to the end to Q, all of them contains S, P, D, and F. Thus, it carries 32 electrons in each main shell of these. Our content for our session will be about, first we'll talk about the periodic table, then ionic bond formation, polar covalent bond, atoms hybridization, for example a carbon atom, shape of molecules in space. For about periodic table, we have a good interactive periodic table found on this link, which have all the atoms, all their structures, all their orbitals, properties, isotopes, even the compounds they are found in this link. Here we have a picture for the periodic table, which we will study about the groups, which are the columns in the periodic table, represent the number of electrons in outermost energy shell. They are named from 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A, which is called inert gases. Also, we have the rows are called periods. The periods represent the number of main shells in each atom. And here we have some colors we have to discuss. For the red color, we have alkali metals, the orange alkali earth metals. For the yellow, transition metals. The green ones are basic metals, the cyan semi-metals, the blue non-metals, the violet halogens, and the purple color or dark violet will be the inert gases. To the next slide, we will talk about some electronic configuration examples like hydrogen gas or neon gas, copper solid, or mercury as a liquid. All of them have electronic configuration. As we will discuss how to electronic configure each of them. Electronic configuration. We start our electronic configuration from subshells, then conclude the main shells. For example, helium. Helium have atomic number of 2, thus while electronic configuring it, we will have one main shell, K, for 2 electrons, while the subshells will be 1s2 for one subshell. That can be easy for atoms which are simple enough, from atomic number 1 to 20. We can do the main shells, then the subshells, no problem. But the issue, when you start after 20, like krypton. Krypton have atomic number of 36. How could you electronic configure it? Starting from the main shells or the subshells? Better here, you have to start from subshells. Let's start 1s2, 2s2, 2p6, and now this conclude for 10 electrons. Let's continue. 3s2, 4s, 3p6, 4s2, and this is conclude for 20 electrons. Let's continue. 3d10, 4s6. Sorry, 4p6. And now this is concluded for 36 electrons. When you draw it in the main shell, it will be like K, L, M, and N. For how many? For K it will be 2 electrons, L 8 electrons, M 18 electrons, and N 8 electrons. Each main shell are completely filled, but does N is completely filled as a main shell? No. Why is this? We have stopped at 4p. 4p as a subshell, it is completely filled, while the other two subshells found in N, which are D and F subshells, both are empty. Empty subshells. This concludes that krypton is one of the inert gases, which are the highly stable in the periodic table. That's why it's high stable, because all of its subshells are completely filled with electrons, while the two other subshells are empty. So there is no repulsion force, no instability, thus it's the highest stable form of an atom in the periodic table. Let's take another example like sodium. Sodium metal. It has an atomic number of 11. Starting from subshells, we will have 1s2, 2s2, 2p6, and 3s1. For the main shell, we will have K, L, M for 2, 8, 1. 1 have 2 electrons. Then the main shell number 1, we will have 2 electrons. 2 have S and P of 8 electrons. Thus, L main shell, which is number 2, will have 8 electrons. While the third subshell, which is found in M main shell, have only 1 electron. And this is for our examples about the electronic configuration. For us, the main shells will help us to find how many electrons will be lost or gained or shared during the formation of a chemical bond. The main shells is the main electronic configurations that will help directly to know the number of electrons that will be shared, lost, or gained during forming a chemical bond. We have 2 types of chemical bonds, 2 main types of chemical bonds: polar covalent bond and ionic bond. We will discuss later in this session. Taking examples like sodium metal, which has electronic configuration of 281 as main shells, and neon, then 3s1 as subshell configuration, with chlorine atom, which has a main shell of 287. Each atom in the periodic table wants to reach its most stable form, like inert gases and noble gases, to complete their main shells. Thus, sodium, the easiest way to complete its main shell is to lose 1 electron and reach neon configuration, which is 2,8. While chlorine has the ability to gain 1 electron and reach the argon electronic configuration, which are both neon and argon are inert gases, and their main shells will be completely filled and reaches its stability. So for sodium metal and the chlorine atom to reach their stability, they have to react. When they react, they form sodium chloride salt, which is called table salt, which we use in our daily life on food or on soups. The sodium chloride salt have an electrostatic force between its oppositely charged ions, forming an ionic lattice in this form. But what if the bond is formed between the sodium positive charge and the chloride negative charge? Is it an attraction force only, or does it has a name? It has a name, the ionic bond. We have here the neutral atoms of sodium, metal, and chlorine gas. The sodium, metal, and chlorine gas each have a number of protons attracting an equal number of electrons in the shells. Let's start our reaction and see what will happen. One electron is lost from sodium and gained by chlorine, producing a positive charge on sodium metal called cation and a negative charge on chlorine atom called anion. Now, for the cation metal, we have a less number of electrons than protons. Thus, the attraction force increases, leading to a smaller atomic size. On the contrary, the chlorine atom gained one more electron. Thus, the number of electrons now is more than protons. Thus, attraction force is smaller, leading to a larger atomic size. Let's take another example that we use in our daily life. The source of life, the water. The water content in our body structure is about 60 to 65%, found in heart, eyes, kidneys, and brain, but mostly distributed in the blood, which is mainly water. The water molecule has a formula of H2O. Thus, these atoms are bonded together by ionic bond like sodium chloride salt, or it has another bonding type. Yes, it has another bonding type, which is the covalent bond. For covalent bond, we have here oxygen atom of electronic configuration 2,6, and each hydrogen atom for electronic configuration 1 electron in K main shell. Covalent bond means sharing of electrons. As we have here, hydrogen atom, each hydrogen atom shared with 1 electron, while oxygen atom shared with 2 electrons. Each bond is formed by 2 electrons. This shared bond is found in like an intersection between the shells. Here we have the hydrogen atom. Each hydrogen atom has completed its main shell. Now hydrogen atom reaches the helium electronic configuration of 2 electrons in K, while oxygen has reached the neon electronic configuration of 2 and 8. How this works? The 2 electrons in each bond rotate around each atom for a certain time. For hydrogen atom, it has rotated for 3 times, while in oxygen atom, it has rotated for 10 times, where sharing of electrons means 50-50 rotation around each atom. Why? Due to electronegativity of oxygen, which is higher than hydrogen. Electronegativity means the intrinsic ability of an atom to pull or attract the electrons found in covalent bond, producing a partially negative charge over oxygen atom and a partially positive charge for hydrogen atoms. Why it is partial? Because they didn't lose the electrons completely. They only lose it for more time than oxygen. In the form of the partially positive hydrogen atom and the partially negative oxygen atom, this molecule is called a dipole. And the covalent bond formed between oxygen and hydrogen is called a polar covalent bond. To the first point of our content, the hybridization process. We have here the carbon atom of 6 electrons, and this is the main electronic shell configuration. For the subshell configuration, we have here energy of orbitals, 1s, 2s, and the 2p orbitals. As we discussed, the s has 1 orbital, while p have 3 orbitals. And we have here the 3-dimensional shape of each orbital. Let's start building up our electrons in each orbital. The first rule for building up, we have to start by filling 1 electron in each orbital. then coupling in with the second electron. The s orbital have a spherical shape on the three-dimensional axis. For 2s, as we said, one single electron in the orbital, then it is coupled. For the p orbital, following the rule, we will fill each orbital by single electron first. For the 6 electrons we have here, 1s2, 2s2 and 2p2. No more electrons to be coupled, and we have the 2pz. The orbital on the z-axis is empty. The second rule for forming a covalent bond, that we must have a singlet orbital, means an orbital having one electron, and each orbital will form a single covalent bond, means we must have an equal orbital energies to form more than one bond. As we said, since the bond requires a singlet orbital from each atom to form a bond, carbon should have formed 2 bonds only. As we see, we have 2 orbitals containing a singlet electron of same orbital energy, which are 2px and 2py. But in reality, carbon forms 4 bonds. How? Through hybridization. Hybridization process starts by when one electron of 2s orbital changes its spin direction and gains some energy, then goes to the 2pz empty orbital, producing 4 singlet orbitals. Then hybridization starts, producing one of 3 possibilities. The first possibility is sp3 hybridization. Hybridization means that we have 4 orbitals combined together, producing a new orbitals with shared characteristics of their parents, but have different shape. As we see, we have here sp3 orbital having half p orbital shape with the spherical shape of s orbital. All of this blue orbital is one orbital containing one electron, and they are found in an energy between the s orbital and the p orbital, where it has higher energy than s orbital and lower energy than p orbital. As we see here, we have 4 orbitals containing singlet or electron of equal energy. Each singlet orbital will form a sigma bond. Thus, sp3 hybridization forms 4 sigma bonds or 4 single bonds. These bonds containing 2 electrons. Thus, there is a repulsion between electrons of each bond, which produces an angle of 109.5 between each bond to reach a stable 3D shape. This 3D shape is called tetrahedral shape. The second possibility we have sp2 hybridization of 3 singlet orbitals of equal energy, with one singlet orbital of higher energy found in 2pz. So we have here 2 different orbital energies, where the sp2 will produce 3 sigma bonds, 1, 2, and 3, while the 2pz orbital of higher orbital energy will produce a pi bond. One pi bond with one sigma bond produces a double bond. The angle between each bond is 120 degrees, as they have a 2D planar trigonal shape for a stable 2D shape. The third possibility is sp hybridization, of having 2 singlet orbitals of same energy and 2py of single electron and 2pz of single electron. Both 2py and 2pz having equal energy but higher than sp hybridization. This will produce 2 sigma bonds of the sp hybridization and 2 pi bonds of the 2py and 2pz orbitals. Thus, 2 pi bonds with 1 sigma bond produces a triple bond. The angle between the bonds will be 180 of 2D shape called linear. As we see here, the sp orbitals, we have the py orbital, the green one, the pz orbital on the z-axis, and two sp orbitals that differs than their original parents, where we have 1, 2, and 3 p orbitals and the spherical s orbital. To summarize, you have learned about the atomic structure, the periodic table, and electronic configuration, the ionic bond for salts, and polar covalent bond, the hybridization process, and the hybridized forms of carbon and its shapes. Thanks for watching. I hope this session will be useful to help you to understand chemistry more and more, even better.